It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
Yes, we expect James Webb to make great discoveries. We expect that.
The U.S. quickly shut down the James Webb Telescope after it exposed what NASA was hiding on Mercury. Near our colossal sun, this small planet is anything but ordinary. It dazzles with unexpected treasures, think diamonds, scattered across its fiery terrain. But beyond the shimmer lies a bizarre and enormous core, defying all previous scientific predictions. What untold stories do these astonishing discoveries hold? Stay with us as we expose the revelations that could upend everything we thought we knew about the planets. Exposing an alien diamond-studded surface. On the face of it, Mercury might seem like just a speck close to the sun, but don't let its size fool you. Beneath that scorching exterior lies a trove of phenomenal secrets. Recently, probes from Earth have unearthed a staggering find. Diamonds are liberally sprinkled across Mercury's landscape. Diamonds on one of the hottest planets in our system, and that's just scratching the surface. Delving deeper, we find that Mercury's core is exceptionally large and peculiar. These revelations prompt a burning question. How does Mercury stand apart from its planetary siblings, and what other enigmatic tales might it be keeping under wraps? Mariner 10 was a trailblazer, as it was the first spacecraft to visit Mercury. It sent back the first close-up pictures, showing a world full of craters and strange ridges, much like our moon. This mission revealed that Mercury had a rough surface, a surprisingly strong magnetic field, and a core that was bigger than scientists had thought, challenging old ideas about what Mercury is made of. But that wasn't the most surprising part. The Messenger mission, launched 31 years later, took our understanding of Mercury to a whole new level. Unlike Mariner 10, Messenger was designed to orbit Mercury, allowing it to study the planet in detail over a long period. It captured about 200,000 images, showing us parts of Mercury we had never seen before, and deepening our knowledge of this intriguing planet. One of the most interesting findings from the Messenger spacecraft was the discovery of unexpectedly high amounts of calcium and magnesium on the darker side of Mercury. This made scientists curious about the natural processes that might have led to such high levels of these elements. They also found that Mercury's magnetic field was much stronger in the northern regions, which was surprising compared to other planets in our solar system. These findings led scientists to realize that Mercury's internal structure and development were quite different from what they had previously thought. On Earth, magnetic fields are usually created by the movement of molten iron within the core. But Mercury's unique internal makeup causes a different type of magnetic activity. What else makes Mercury's landscape stand out? Besides its craters and ridges, the planet faces extreme environmental conditions. During the day, temperatures on Mercury's surface can reach up to 806 degrees Fahrenheit, hot enough to melt lead. On the other hand, at night, temperatures drop sharply to about minus 292 degrees Fahrenheit. This huge temperature swing happens because Mercury's thin atmosphere doesn't help much with temperature regulation or heat retention. But the extreme temperatures aren't the only surprising thing about Mercury. More recent studies have uncovered some unexpected features on its surface. In 2012, data from Messenger showed signs of volcanic activity, including evidence of past explosive eruptions. This finding challenged the earlier belief that Mercury was geologically inactive. Then in 2020, researchers made an even more intriguing discovery. They found water ice in some of Mercury's permanently shadowed polar craters. These areas, always shielded from the sun, are cold enough to keep water frozen, even though Mercury is so close to the sun. The presence of ice raised new questions about whether Mercury might have the potential to support basic life forms. Could there be life forms similar to those found in Earth's harshest environments, surviving in these icy pockets on Mercury? This question opens up exciting possibilities for understanding how life might endure under different planetary conditions. But that's not the end of the story. In 2018, a spacecraft named Bepi Colombo was launched towards Mercury, thanks to a partnership between the European Space Agency and the Japan Aerospace Exploration Agency. It's set to reach Mercury by 2025. Once it gets there, Bepi Colombo will collect detailed information about the planet, including what's on its surface and its geological history. Surprisingly, despite Mercury being so close to the Sun, it has a strong magnetic field and even some water ice. But here's something even more surprising. Mercury has a day that lasts longer than its year. When we think about planets, we usually imagine them spinning on their axis once every day and orbiting the Sun once every year. But Mercury is different. On this small, scorching planet, a single day is actually longer than a whole year. Let's explore Mercury, where a day lasts longer than a year, a symphony of sun and shadow. To put it simply, Mercury takes only 88 Earth days to complete one orbit around the Sun, making its year much shorter than ours. However, one full day on Mercury, meaning one complete rotation on its axis, takes about 176 Earth days. So a year on Mercury is just half as long as a day. This leads to some very strange effects. If you were standing on Mercury, you would see the Sun rise and slowly get bigger as it moves across the sky. But then something unusual would happen. The Sun would appear to stop, move backward a bit, and then continue on its way. This strange movement happens because Mercury spins so slowly compared to how fast it orbits the Sun. But that's not the strangest part. Why does Mercury rotate so slowly in the first place? The answer lies in something called tidal locking. Over billions of years, the Sun's gravity has gradually slowed down Mercury's spin. Unlike the Moon, which is fully locked to Earth, Mercury is in a 3-to-2 spin-orbit resonance. This means that for every 2 orbits around the Sun, Mercury spins 3 times. These unusual spinning and orbiting patterns create extreme conditions on Mercury, especially because of its odd day-night cycle. The side of Mercury that faces the Sun gets extremely hot for months on end, while the side facing away from the Sun remains in freezing darkness for just as long. This leads to some of the most drastic temperature changes in our solar system. When we talk about Mercury's atmosphere, it's important to note that it doesn't really have what we consider a true atmosphere. Instead, it has a very thin layer called an exosphere. This layer is so sparse that it constantly escapes into space, and it's only occasionally replenished by things like solar wind, the decay of radioactive materials, and impacts from tiny space rocks. Recent studies have uncovered some surprising details about Mercury's exosphere. In 2020, data from the Messenger spacecraft revealed that there is more water vapor in Mercury's exosphere than scientists previously thought. This water vapor likely forms when hydrogen from the solar wind reacts with oxygen in the rocks on Mercury's surface. Another fascinating aspect of Mercury is how quickly it orbits the Sun compared to its relatively slow rotation on its axis. This unusual combination affects its magnetic properties. Even though Mercury is small and spins slowly, it still has a significant magnetic field, which was an unexpected discovery for scientists. Further studies suggest that this magnetic field is generated by unique internal movements within its liquid metallic core, influenced by Mercury's particular spin and orbit. But the fact that this magnetic field is weaker than Earth's is still very important. It protects Mercury's surface from the powerful solar wind. Without this shield, the solar wind would do an even better job of thinning out Mercury's already thin atmosphere. Mercury's quick orbit around the Sun, combined with its slow spin, creates some interesting situations. There are places on Mercury's surface called hot poles, where the Sun appears to stop in the sky for a while, causing these spots to get extremely hot. On the other hand, areas near Mercury's poles remain in constant darkness, allowing ice to exist even though the planet is so close to the Sun. This happens because of Mercury's unique spin and orbit around the Sun. The craters in these shadowy areas never see sunlight, so they stay very cold, even while the rest of the planet is burning hot. Scientists are now wondering if other materials, maybe even organic ones, could be hiding in these icy regions. Mercury's fast orbit and slow rotation also affect how we study the planet. Its quick journey around the Sun makes it a tough target for spacecraft. To slow down enough to get into orbit around Mercury, spacecraft have to use complex navigation techniques, including several flybys of both Venus and Mercury. The Bepi Colombo mission is currently using these flybys to adjust its speed and path. Launched in 2018, Bepi Colombo is expected to start orbiting Mercury by 2025 after 9 flybys. Once there, it will face challenges from Mercury's unusual day-night cycle, which will require careful management of its temperature and power to survive. Digging deeper, Mercury's secrets start to unfold, an odyssey into the planet's core. But that's not the only challenge. Recent studies suggest that Mercury might have once spun faster, but slowed down over time due to the sun's gravity and possible collisions with other celestial bodies. This finding not only helps us understand Mercury's history better, but also gives us more insight into how planets in our solar system evolve. As we continue to learn more, new questions about Mercury's inside and surface come up. Scientists are curious about its core, which seems partly fluid despite the freezing temperatures, and how its strange orbit affects its geological features. These ongoing discoveries keep the scientific community excited about what more we might learn about Mercury. Mercury keeps surprising scientists and challenging what we know about how planets form and evolve. So what other secrets might this tiny, crater-filled planet be hiding beneath its surface? Even though Mercury is the smallest planet in our solar system, it's full of mysteries that puzzle researchers. Its small size doesn't stop it from having some really unusual features. One of the most fascinating things about Mercury is its huge core. Dr. Nancy Chabot, a planetary scientist, led a study showing that Mercury's core makes up about 85% of the planet's total volume. To put that in perspective, Earth's core only makes up about 15% of its volume. This raises a big question. Why does Mercury have such a massive core? One popular idea is that Mercury used to be much bigger, but lost most of its outer layers in a giant collision early in the solar system's history. This theory, known as the hit-and-run scenario, was proposed by Dr. Eric Asfog. He suggested that a large object might have crashed into Mercury, stripping away its outer material and leaving behind the iron-rich core we see today. But Mercury's surprises don't stop there. It also has a magnetic field, something scientists didn't expect from such a small, slowly rotating planet. Unlike Venus and Mars, which don't have global magnetic fields, Mercury has a magnetic field that's about 1% as strong as Earth's. This discovery, made by NASA's Messenger mission, left scientists scratching their heads. Then came another twist. Dr. Katherine Johnson and her team found that Mercury's magnetic field isn't centered. It's actually offset by about 20% of the planet's radius. This strange shift might be connected to differences in Mercury's crust, which could affect how heat escapes from its core. As if that wasn't enough, in 2020, researchers found that Mercury's surface contains volatile elements like sulfur, potassium, and sodium. This adds even more intrigue to an already complex planet, sparking more questions and new studies as scientists try to piece together Mercury's many mysteries. But these discoveries only scratch the surface of what Mercury might still be hiding. What else could this small planet reveal? It's surprising to find certain substances that usually evaporate at high temperatures existing on a planet so close to the sun. Dr. Patrick Poplawski from the Johns Hopkins Applied Physics Laboratory has an interesting idea. He suggests that these substances, which quickly turn into gas, might have arrived on Mercury much later, brought by comets or asteroids after the planet formed. One of the most exciting discoveries on Mercury is the detection of water ice inside craters at the poles that are always in shadow. Dr. Nancy Chabot, who we've mentioned before, played a significant role in this research. These icy patches stay frozen because the warmth of the sun never reaches these craters, keeping them extremely cold. What's even more fascinating is the discovery of organic material in these icy spots. Scientists have found dark areas that could contain complex carbon molecules, similar to the ones that might have helped start life on our planet. Could it be that Mercury, with all its extreme conditions, holds clues about the beginnings of life in our solar system? Mercury has more surprises when it comes to its geological activity. For a long time, scientists thought Mercury was geologically inactive, but the Messenger mission brought new information, suggesting recent volcanic activity. Dr. David Rothery from the Open University in the UK found what looked like small, shiny volcanic vents on Mercury's surface. These features, called hollows, hint at ongoing geological processes on the planet. Next, we find chaos and mystery in Mercury's terrain. Mercury's chaotic heart. One of the most puzzling geological features on Mercury is its chaotic terrain, a large jumbled area of hills and valleys near the southern pole. Discovered during the Mariner 10 mission in the 1970s, this region is about the size of Texas. Dr. Thomas Waters from the Smithsonian Institution believes that massive quakes, possibly caused by the sun's gravitational pull as Mercury's orbit changed, could have shaped this landscape. But that's not all. Recent studies have given us a better understanding of Mercury's inner structure. Dr. Amir Khan from the University of Zurich used data from the Messenger mission to study Mercury's internal makeup. His research suggests that, like Earth, Mercury has a liquid outer core and a solid inner core. However, Mercury's inner core is much larger in proportion, which might explain some of its unusual magnetic properties. These surprising features of Mercury make us rethink how planets form and change. They remind us that even close to home, in the vastness of space, there are many more discoveries waiting to be made. As we look forward to more explorations and findings, we can only imagine what other interesting details lie hidden beneath Mercury's surface. The recent investigations and missions show that Mercury's mysteries are as intriguing as anything visible on its surface. Mercury's inner structure is truly fascinating. While Earth has a solid inner core surrounded by a liquid outer core, Mercury is the opposite. It has mostly a liquid core with a solid center. This was confirmed by NASA's Messenger mission, which studied Mercury's gravity to learn more about what's inside the planet. Mercury's solid center is about 1,260 miles, 2,000 kilometers wide, making up about half of its entire core. On Earth, our solid core only makes up about 20% of the core's volume. This difference in size and composition is important because it helps create Mercury's magnetic field. Although Mercury's magnetic field is weaker than Earth's, it's still quite strong for such a small planet. Right above Mercury's core is a surprisingly thin layer of mantle. Scientists now think this mantle is only about 260 miles, 420 kilometers, thick, which is much thinner than Earth's mantle, which is around 1,800 miles, 2,900 kilometers thick. This thin mantle affects Mercury's geological activity and how the planet distributes heat. But that's not all. There's more to Mercury than meets the eye. In 2012, the Messenger mission discovered evidence of ancient volcanic activity on Mercury. The probe found unique, shallow depressions called hollows, which were formed when volatile materials at the surface evaporated, suggesting that Mercury had more of these materials than we once thought. Then in 2020, scientists used data from Messenger to find signs of a large magma reservoir that existed beneath Mercury's surface long ago. This ancient sea of magma likely played a key role in shaping both the surface and deeper layers of the planet. This magma sea helps explain why Mercury's surface has vast, smooth plains, especially in the northern hemisphere. These areas, known as the northern volcanic plains, were likely created by large lava flows early in Mercury's history. But Mercury's surprises didn't end there. In 2022, researchers uncovered even more secrets hiding beneath Mercury's rocky surface, showing us that this planet still has many stories to tell. Scientists studying data from the Messenger spacecraft have found evidence of nitrogen hidden beneath Mercury's surface. This nitrogen could be the remains of what might have been a thick, ancient atmosphere that got pushed underground due to the planet's intense heat and constant exposure to solar radiation. This discovery opens up exciting questions about Mercury's past. Was its atmosphere once much thicker? What does this tell us about the planet's ancient conditions, and could it have possibly supported life in some way? Mercury also has water ice hidden in the dark craters at its poles. Although this ice is on the surface, it stays hidden from the sun's rays, protected by the extreme cold in these shadowy areas. Recent studies suggest that some of this ice is relatively new, likely delivered by comets or asteroids in the last few tens of millions of years. Now we see signs that Mercury is still changing today, exposing geological mysteries. But that's not all. These dark patches in the polar craters are also thought to contain organic matter, possibly brought there by the same space impacts. This organic material, which is less stable than the water ice, offers a unique opportunity to study how organic molecules are distributed in the inner solar system. Mercury's subsurface features also provide clues to its geological history. Unlike Earth, Mercury doesn't have plate tectonics, but it shows clear signs of having shrunk as it cooled. This is evident in the many thrust faults across its surface, where parts of the crust are pushed upward over others, sometimes reaching heights of several kilometers. These faults reveal much about Mercury's internal makeup and its geological past. But here's where it gets even more interesting. Further research into these faults suggests that Mercury might still be geologically active. A study published in 2019 found evidence of grabens, which are small valleys created by the stretching of the crust near some of the planet's largest faults. These features appear to be relatively young, hinting that Mercury's crust is still changing. And then there's Mercury's magnetic field, which is different from Earth's. While Earth's magnetic field comes from molten iron moving in its outer core, Mercury's field likely comes from a different process, sparking further curiosity about how magnetic fields are formed on other planets. Researchers are now looking into the idea that Mercury's magnetic field might be caused by liquid metal flowing around the planet's solid inner core. This process is similar to what we see in other planets and stars, suggesting that Mercury has a surprisingly complex and active interior. But there's more. Scientists are also very interested in what lies beneath Mercury's surface. They believe that there could be many cracks and fissures under the planet's crust. These could allow heat, and maybe even fluids, to move between different layers of the planet. This idea is particularly intriguing because it suggests that Mercury, once thought to be geologically dead, might still have some active processes going on inside. Even though Mercury's surface is dry and barren now, some researchers think there could be pockets of water hidden deep below the crust. If these water reservoirs exist, they might be leftovers from a time when Mercury had a more temperate climate, or could be kept liquid by the planet's internal heat. This idea is similar to what we found on moons like Europa and Enceladus, where hidden oceans exist beneath thick layers of ice, challenging what we know about where life might exist in our solar system. The possibility of water on Mercury could lead to new research on the planet's past environment and its ability to support chemical processes essential for life. If water is found, it could reveal important details about the planet's geological history and raise new questions about the chemical interactions happening below the surface. But this isn't just about Mercury. Studying its interior helps scientists learn more about how rocky planets like Earth formed. Understanding Mercury's geological history, its volcanic activity, and the makeup of its core is crucial for building a complete picture of how planets in our solar system, including Earth, have evolved over time. Every new discovery about Mercury adds to our knowledge and offers fresh insights into the early days of our solar system. For instance, studying trapped gases and other substances beneath Mercury's surface could reveal much about the planet's ancient atmosphere and the conditions that existed billions of years ago. Looking forward, there's growing excitement about future missions to Mercury. These missions will use advanced technology to explore Mercury's surface and its hidden depths. With each mission, we hope to learn more about this mysterious planet and its place in the larger story of our solar system. Mercury, despite being close to the Sun and small in size, is still full of mysteries. Exploring its depths doesn't just help us understand Mercury itself, but could also unlock secrets about how our solar system formed and evolved. Studying Mercury offers a unique opportunity to understand how the Sun influences the planets, making it a central focus in the field of planetary science and exploration. What discoveries might challenge our current understanding of the solar system? Comment, like, and subscribe for more.